Welcome to the first edition of Nahar JITO Bookathon, presented in association with Raisuni Foundation. Viewers, in this session, we explore the book Chandrayaan-3, India on the Moon by Dr. Ajey Lele. As we all know that on 31st of August 2023, India scripted history as Chandrayaan-3 successfully landed on Moon's south pole. India became first and only country to reach this remote lunar region, a milestone that has elevated India to the ranks of United States, Russia, and China. The only three other nations have reached to the moon. But these were not the only records Indian Space Research Organization ISRO had made that day. It has also garnered over 8 million concurrent views of the live moon landing on the YouTube, the highest ever in the history of the platform. This book offers an overview of Chandrayaan-3 mission and covers the evolution of India moon program. It traces India's journey to the moon starting from its inception during early 2000. We would like to touch upon the fact that yes, the ISRO, the institution which has made a huge difference when it comes to India's moon mission. We are privileged to have our speaker today, Group Captain Ajey Lele, who is currently working as Deputy Director General in Manohar Parrikar Institute of Defence Studies, and prior to that he had worked in the same institution as senior and headed its Center of Strategic Technologies. Dr. Lele started his professional career as an officer in the Indian Air Force in the year 1987 and took early retirement from the services to pursue his academic interests. He has a master's degree in physics from Pune University and then master's and MPhil from in defense and strategic studies from Madras University. He has done his doctorate from the School of International Studies, JNU, New Delhi. His specific areas of research include issues related to weapon of mass destruction, space security, and strategic technologies. He has contributed articles in various national and international journals, websites, and newspapers. He has authored 10 books, and he has been an editor for 7 books. He is a recipient of prestigious K. Subramaniam Award 2013, which is conferred for outstanding contribution in the area of strategic and security studies. Group Captain Ajey Lele is on editorial committee of Journal of Defence Studies. Looking at the expanse of the work Dr. Lele has in the past so many years, it is so interesting to know so many things about him. Though we will be restricting ourselves to Chandrayaan-3, the book which he has penned on India with the title Chandrayaan-3, India on the Moon. And we'd like to know all the insights about this book, how this book was conceptualized, other questions which we would like to know from Dr. Ajey Lele. I'm sure that each one of us is going to have a very interesting conversation with Dr. Ajey Lele, and we would like to know many things about it. And in fact, I would like to begin, sir, with a very elementary question. And the very question was, how this idea came to you to pen down a book on Chandrayaan-3?
You see, a couple of years back, I had written a book on India's Mars mission. So when India was planning India's mission to Mars, that is Mars orbital mission, that point in time I had gone to ISRO. I was helped by ISRO giving enough amount of information about India's Mars program. So after that, I was working on various other programs of ISRO. So I ended up writing a book actually on ISRO itself, that how their journey has began and where it stands today. So since I was following their programs, I thought that this is a very interesting program and India has got a success in this program. Because in Chandrayaan-2, it was a partial success, one can say. So I thought that it is a successful program, and as a layman, because I'm not a rocket scientist, but as a student of science and international relations, I thought that as a layman, I can bring out both the perspectives. a scientific
Right.
perspective also, and a perspective which is related with policy. That's the reason I ended up writing this book.
Right, sir. Sir, we would like be interested into more into as common man. We would like to be we'll be more interested to know not only the policy and the science part of it, how this journey, because it had been a very emotional journey. We had seen the if I take something in the backdrop of what happened in Chandrayaan-2, we had almost made it,
Yes.
and something happened at the very last moment. And we all have seen on the screen how a scientist also feels a human being. So my question is, sir, what were the key challenges ISRO faced during this Chandrayaan-3? Because on the backdrop of this failure of Chandrayaan-2, if I may say so.
You see, as far as Chandrayaan-2 mission was concerned, the mission had two components. One component was to launch an orbiter and make it
Sir,
stable into the lunar orbit and start taking observations. The other
correct.
component was to have a rover and a lander system which would land onto the surface of the moon. What it is said that it will do a soft landing, then the
Correct.
rover will come out of the belly of a lander and will start functioning and collecting observations. It
Right,
so
sir.
happened that the orbiter system, which was along with the Chandrayaan-2 mission, was perfectly put into the orbit of Moon. However, while landing the rover and lander system, some malfunctioning happened, and at the
Okay.
last moment, it instead of having a soft landing, it did a hard landing. You see, the last 35 kilometers, when you are approach to the moon, that time by Chairman ISRO, it was said that this is a period of very tension for last 15 minutes when that entire
Correct.
journey from 35 kilometers towards the lunar surface was starting. So it was a
Very true.
journey they described as a period of a horror and all that. But actually, it was a journey where scientists were really looking at things, how their various parameters are functioning, how the spacecraft is actually making towards landing towards the moon. It so happened, unfortunately,
Correct.
that just 2.1 kilometers above the moon surface, there was some disturbance.
Very
They
true.
call that as a software glitch which happened. And instead of doing a very smooth, soft landing, it ended up doing a hard landing. So since it was a hard landing, there was a lander which was supposed to have a rover inside its belly. And both the lander was supposed to pick up observations and the rover also was supposed to pick up the observations. The rover is a small buggy sort of a system which was supposed to get out of the belly of a lander, move on the lunar surface and pick up observations. But since it was a
Very
hard landing, the rover never got an opportunity to get out of the lander system. And the lander also had a very hard fall, so no observations were picked up. So in a sense,
okay.
I can say that this mission was partially successful because we were able to put the orbiter into the orbit of the moon. Now, why this orbiter is required? This orbiter is required
So
to
this
identify. Yes.
you were saying something, sir?
Yeah, I was just giving an explanation that why this orbiter was launched along with this system. Because you require a satellite into the vicinity of the moon, which will collect all the pictures continuously, so that you come to know that where is the exactly a good landing spot could be. Second thing is
Right.
that to help communications also. From the moon surface, the rover and a lander system will communicate with orbiter, and the orbiter will communicate with the Earth system, which is on the surface of the Earth, the ISRO's Earth
Correct.
station. So that's the
Correct. Correct.
reason this orbiter was launched. Initially, it was thought that this orbiter will have a life of 1 year, but
Correct.
subsequently, since the mission was so successful, that in the successful mission, a lot amount of fuel saving had happened. So after the
Correct.
orbiter was established in the vicinity of a moon, ISRO realized that it can last for 7 years. So for
Okay.
Chandrayaan-3 mission, there was no requirement of sending an orbiter. The existing orbiter only
Okay.
helped us.
Right, right, right. In fact, that was my next question, that what's happened in Chandrayaan-2, how did you overcome when it comes to the landing part? So any specific thing in addition to what we did in Chandrayaan
No,
3,
definitely.
which we did not? So please.
See, we learned from our experiences. Since
Correct.
the failure came only just 2.1 kilometers above
Very
the moon surface, and things had gone not as per the plan. So now what
correct.
happens is that when you're sending a craft to that height, particularly moon is around 4 lakh kilometers from the Earth's surface. So every system is in autonomous mode. That means there is no control onto the surface of the Earth to tell that system if something goes amiss here and there. So there is a
Correct.
software which is built into the system. That software takes decisions at right point in time, that how to behave, whether to increase the speed, whether to reduce the speed, whether to change the direction where it is going to land, where to change the landing zone also. So all these decisions are taken autonomously by that particular system based on the software. Now you are
Okay.
picking up inputs from the orbiter as far as landing sequence is concerned, which could be the best possible location for the landing. Now what happens is that that software is a software. So it depends on what has been taught to the software. So there was a realization that the software was not able to do the course correction at the last moment when things were going wrong, because that software was not equipped with multiple options. So what
Correct.
ISRO did was that during Chandrayaan-3 missions, they actually went on to doing a lot amount of simulation exercises for different type of touchdown conditions. So these simulation exercises actually help them to understand that what could be the possible challenges. Initially in Chandrayaan-2 mission, the software was told that these could be the possible challenges. But more amount of a thinking based on our own failure, then there were certain other failures also which were happening in the world. There are other successes which were happening in the world also. So what ISRO decided is to develop a system which is a failure-based system. If you decide a system which is a failure-based system, that means if I have to quote the wordings of ISRO chairman that time, that they worked on all known unknowns. So they had taken so much of a precaution that if A goes wrong, what should be done? If B goes wrong, what should be done? So the software was made so strong that almost all known options of a failure were fed into the software, and the software was taught that if that sort of a situation arises, what should be the course correction mechanism which should be used. So that is the work on a software which happened. Otherwise, on the system itself also the work happened. Like your rover and a lander, it is essentially a one unit. That is a lander unit. The rover is put inside the belly of a lander. So that lander has to make a soft landing. That means it should have very strong legs. So the legs were strengthened as compared to Chandrayaan-2 mission. To strengthen those legs, certain amount of a simulation exercises were carried out. By helicopter, the landers were picked up. The lander was dropped down with a particular velocity, just to ensure that whether that lander can sustain those sorts of velocical changes or whatever whatever small things which could happen, which could go wrong at the last moment. Then initially when we had launched Chandrayaan-2 mission, we had a lander which had 5 engines. There was a consensus among the scientific community that you need to reduce these 5 engines to 4 engines, because unnecessarily it could increase the velocity, which is not desirable at that point in time. So the work was done, major work was done on a software, but at the same time, some work was done on a hardware also, that even if there is some sort of a small hard landing, still the legs should be so strong that a lander you should be able to sustain it over there. That's the way the scientists had overcome the challenges which were there in Chandrayaan-2, and that is the only reason why we got a success in Chandrayaan-3, because almost everything was taken care of.
Okay, that's great. In fact, sir, anticipating something which is going to be at very far off place where we'll not have any direct control, or we had just have to see and watch what is going to happen.
Exactly.
But I'm sure that it takes a lot of efforts and a lot of thought process behind it, and you must have all sit together and coming out with these things, like thinking of those making legs stronger, or taking care of velocity by reducing the load, and then having simulation processes. That's wonderful. We hardly get to know as common men that what is being done at the end. We see the institution, we see the scientists, we see the efforts at the end. But I'm sure that it must be taking a lot number of years. How much one mission takes normally, sir, in terms of years?
You see, it depends on your first mission. Like
Sir.
we did a very successful mission in 2008, that is the Chandrayaan-1 program.
Very true.
The
Very true.
conceptual of a mission started happening around 2000, year 1999 to 2000, when in Astronomical Society of India, there was a thinking which came out that we need to now look at the other planets also, since we have got a reasonably successful space program. So one can say that it takes around 5 to 6 years to conceptualize mission, to put it on a drawing board, to start making prototypes, and finally delivering the thing out into the space, particularly on the moon area.
Correct.
2008 moon mission was not a landing mission, it was an
Sir.
orbital mission where we first decided to enter into the lunar orbit. Because you see, what happens is that as you leave the Earth's orbit, the challenges are different than what are there for your normal satellites. Because your
True.
normal satellites, the maximum height a satellite is normally being put is in a geostationary orbit that is around 36,000 kilometers above the Earth's surface.
Sir.
But here you are trying to reach 4 lakh plus kilometers above the Earth's surface. So
Oh.
as you leave Earth's gravity, Earth's atmosphere, and try to enter into the lunar gravity, because as compared to the Earth's gravity, lunar gravity is just 1/6 of Earth's gravity. So there are
Correct.
different types of challenges which occur over there. So first, to enter the lunar orbit itself is a challenging thing, and to establish a satellite over there, which will keep on taking observations, is the other challenge. So we had overcome that challenge in the year 2008 itself. So we had understood, we have successfully demonstrated that how to enter into the lunar orbit and position of satellite over there and start taking observations. So naturally, since the major job was done, for the second
Sir.
mission, the challenge was only to develop a rover and a lander system. But you can see that in 2008, we did the first mission, but it took good amount of a time for the third mission to become successful. One of the reasons was that India was depending on Russia because India's second mission was supposed to be a joint mission where India
Sir.
was supposed to launch the satellite and Russia was supposed to give us a rover and a lander system. But since
I see.
Russia said that they are not being able to do it because of some internal problems in their space program, so Indian
Correct.
scientists took on themselves around the year 2015-16 to develop a rover and a lander system on our own. That's why you can see that there is a much amount of a difference in the launch of a first mission and the third mission where rover and a
Correct.
lander mission was there. Because we were depending on Russia and since they had said no, so India scientific community took it on their own to develop those systems and they have successfully developed those systems.
Okay, so earlier I thought that probably a lot of international collaborations are taking place, but now I understand, as you stated.
Can you repeat the question,
Yeah,
please?
yeah. Earlier I thought that probably this all missions require a lot of international collaboration, and as you stated that we were relying on Russia for rover and landers. But when it comes to Chandrayaan-3 and with the problem Russians they faced about their own space issues, so may I say that this is something which is purely indigenous when it comes to Chandrayaan-3?
You see, one can say that most of the parts of these systems are indigenous. We
Sir.
had some amount of, because basically what happens is that it's not only sending system to the moon or to the
Sir.
Mars. You require communication facilities. You
Right,
require
right.
a solid ground infrastructure. So all those things, certain amount of assistance was there. I will say that assistance was known, particularly NASA had helped us. But one of the most
Okay.
important aspect of India's moon mission, particularly Chandrayaan-1, was that you see when you go to the moon, you carry certain amount of sensors to do certain
Correct.
amount of observations. So as far as
Correct.
India was concerned, India has carried the sensors for other countries also. So more than an international collaboration, I can say over here that India's mission had helped the other countries, gave them a ready-made
Okay.
platform to undertake observations on the lunar surface. So we had a NASA sensor also on board of in the 2008 mission and few other countries also. So there were 5 sensors which were from the outside India sensors. So India
Okay.
has helped the other countries by giving a
Wonderful.
good platform to undertake observations.
Okay, that's very great and very glad to know these things. Like how Indian scientists are actually marching and helping the other countries. Because I understand, sir, that most of the missions initially started in the 1950s when it comes to the moon missions, and
Yes.
mostly Russia and it was USA. They were having the major role to play. Probably earlier they were having some flyby kind of expeditions where they were just trying to explore through a distance. They were trying to explore moon as such. Sir, a layman's question. Why are we, mankind, why are we so much interested in exploring moon? And what do we get at the end, like, out of this? Because, yeah, a lot of competition is going on. In fact, I understand when India, landed on the southern pole, China probably talked about some 1 degree is 1.5 degrees of deviation, some difference kind of things. So on one hand, I see a competition. On the other hand, I have a curiosity why we are so much for these kind of missions. What do we want to explore, and how will it help the mankind on the Earth out of these expeditions?
Interesting question. There are 2 to 3 reasons to it. One
Sure,
is that as a human being, as a scientific community, we are very curious that what is there
absolutely,
to the world.
very true,
You
very
see,
true,
if a scientific community is not curious, then for all these years, the science would have not progressed the way it has progressed.
absolutely, very
So
true, very true.
curiosity is one very important aspect associated with it. The most important aspect which was associated with moon missions, particularly with the Apollo program of the United States of America during early 60s. Subsequently, we had a landing close to 1970s by Neil Armstrong, the first
Sure,
human go to the moon. There are 12 people who have reached to the moon and they have walked onto the surface of the moon. All of them are the American astronauts. You
sure,
see, that was a period of a Cold War era. So there was a
correct,
good amount of power politics which was happening. It was a period when there were two power blocks which were competing with each other as far as technology domination is concerned.
correct, correct.
USSR was having nuclear weapons, so is the case with USA. After
Sure,
particularly post Hiroshima and Nagasaki, there was good amount of work which was happening in the arenas of nuclear weapons. They were trying to develop nuclear weapons as a method of a deterrence because everybody understood what impacts on the humanity it happens because of the bombing of Hiroshima and Nagasaki. So to develop a method of a deterrence, you need to have very strong technology base. It so happened that Russia, the USSR at that point in time, launched the first satellite in the year 1957. So that was the
correct.
first satellite called Sputnik which was launched. Obviously, the USA also was working on satellite technology and they responded to it by launching their own satellite in 1958, just within 4 months, 5 to 6 months of time after USSR had launched satellite. But the
Correct.
basic challenge to the technology domination, and you see, technology domination is not only to have a technology, it is a demonstration of a technology to the rest of the world. It so happened that 1961, USSR was successful in putting human into the space called Yuri Gagarin. So that was a very
Correct.
great movement called Gagarin movement. The entire world realized that the USSR is far more technologically superior than the USA. And trust you me, that's the only reason why NASA was asked. They were not given a program to go to the moon. They were asked that you do something so humongous and something so mind-boggling that people will understand that yes, the USA is the leader in technology. And that's the
Okay.
reason NASA decided to go to the moon. Because if
Okay.
you follow the entire moon missions of Apollo program, it was a very costly mission. That was the
Sure.
most important reason why NASA decided not to go ahead with further missions. But more importantly, it was a technology demonstration mission. So there was no idea of what to do after you reach to the moon. So the
Correct.
astronauts went there, generally jumped around, collected a few samples of the stone and got back. But there was no
Okay.
scientific agenda which was associated with the moon at that point in time. It was a
Right.
technology demonstration and more as a power projection, which was there in the era of a Cold War. But now, when all countries are going to the moon, there is a major amount of a scientific agenda.
Sure.
What could be that scientific agenda? Like I told you, number one, curiosity. Number two, we want to see that why moon is existing in this particular fashion. Uh,
Right.
is there a change in atmosphere over there? Can humans sustain out over there? So there are various questions which are in the mind of the humans, and sitting over here, you just don't get answers to those questions. So you have
Correct.
to
Correct.
reach there to find the answers to those questions.
Right. Very
The
right.
two thing is that there was a realization that there could be a lot of minerals available on the moon surface. You understand today we require a lot amount of minerals, particularly rare earth elements and all that for our semiconductor
Correct.
designs, chips and all that.
Correct.
And there is a very limited quantity of minerals which is available on the earth's surface. So we have almost
Sure.
exhausted whatever is available on the Earth's surface. So if you want your electronics industry, other industries to sustain, then you require a continuous supply of minerals. And there is a scientific understanding based on the geological aspects and other aspects of the moon surface that there could be a lot amount of minerals available on the moon surface. So to get back those minerals back to the Earth is going to be exceptionally costly affair. But you have to start somewhere. What I'm trying to say is that it may happen after, say, 2 decades, 3 decades, where you can get the minerals back from the moon surface. But until unless you don't start, you will be lagging behind. And that's the reason,
Right.
apart from the Russia, US, and other countries like India, Japan, even Israel, have started looking at the moon because everybody understood that if you've got a program which is matching with other countries' programs also, then you can also be there and get the advantage of getting minerals. Another important aspect as far as moon is concerned is there is a availability of a substance on the moon surface called helium-3. Now, why this substance is important? This substance is important because theoretical calculations suggest that you got a nuclear industry. You see, the entire world is a power-hungry world in a sense. Yeah, I'm sitting in Delhi, temperatures of 47 degrees Celsius. Definitely, you require power to run your ACs and other things. So everybody understands the energy requirements per se. So it is said that if you can get the helium-3 back, say one Boeing load of helium-3 from the surface of the moon, it will help you to change the existing pattern of a nuclear energy generation in such a great fashion that it will resolve the energy crisis for the entire world for coming 10 years or so. So these are theoretical calculations, but helium-3 is not available on the moon surface. So you require to get that helium-3 back, do a experimentation, and actually understand that whether it will be helping us to resolve the existing energy crisis. So there is a lot amount of a scientific agenda which is associated with the moon now, and that's the reason why every country is trying to reach there.
And right, in fact, this just came to my mind because I felt that all these expeditions, how is it going to help the mankind? And in fact, I got a very elaborative answer on this particularly. But one more thing in this particular thing, when this Chandrayaan-3 was discussed, its success was, celebrated. One thing which constantly came, like it landed on South Pole, and which no other country could do. So, what is the significance of landing on South Pole, and what is that we are going to get out of it?
You see, it's a very tricky situation which India was facing while landing on the South Pole. You made that reference to Chinese saying that there is some difference and all that.
Yeah,
I'll just
1.5
explain.
degrees.
Yes, I will just explain that also in this process of this answer. When you talk technically speaking, when you talk of a South Pole, that means on the southern border. When you look at a latitude-wise, longitude-wise, and all that. Particularly from the point of a latitude, you should be at 90 degrees. We landed at 68 degrees. So the Chinese were saying that that means you're not landed at 88 or 90 degrees, you landed at the 68 degrees. So that's not a South Pole landing, technically speaking. In a sense, the Chinese could be correct. But India had a reason to do that. In the 2008 mission to moon, India, along with the observations which were picked up by the NASA sensor. NASA had two sensors at that point in time on India's Chandrayaan mission. One sensor was a moon mineralogical mapper. Then there was a sensor which was basically a small mini synthetic aperture radar. So these sensors actually help NASA to identify the presence of the water on the lunar surface. India also had a moon impact probe. In those days, Dr. Abdul Kalam had suggested that if you're reaching as close to the lunar surface and revolving a satellite out over there, we need to have India's imprint on the lunar surface also. So that satellite had a moon impact probe. So that probe was released onto the surface of the moon. So while releasing that probe towards the surface of the moon, a lot amount of observations were picked up. So those observations also indicated that there is a possibility of presence of water on the moon surface. So the water on the moon surface is not like H2O, what we see and drink. It is you can say a part of a water system, which is what you can say, it's a very not fossilized, it is a frozen water system which is possibly out over there. Now, the possibility of that sort of a water is only at a southern pole. The simple reason for that is that the sun is not able to reach the southern pole. So when you're close to the southern pole, the scientists, based on various observations which were taken by satellites and all that, had a broad understanding that there is a possibility that we will find a water close to the southern pole. So there was a requirement of landing close to the southern pole. But as I explained it to you, around 87 to 90 degrees could be a southern pole. But we decided to land slightly ahead of it. There was a reason behind this. Because you see, as you go to the moon, your energy requirements for allowing the system to function is based on solar energy. So at southern pole, there is no sun. So you can't operate your equipments over there because there is no solar energy available over there. So we wanted to find a location where solar energy is also available, but at the same time we can slightly do some amount of a digging in a sense of taking observations where we are very close to the southern pole. So there's a possibility that we will get some idea about the presence of water. So that is the main reason we decided to land around 70 degrees because we could have landed at 90 degrees also. So when Chinese were saying that you're not landing at 90 degrees, theoretically they're right. But practically we found that to land at this particular altitude, at this particular latitude is very helpful because we will get a sun also to undertake our systems functioning. At the same time, we are very close to the South Pole, so we will be able to identify the presence of a water also. So these were the reasons why we did this sort of experimentation.
Right, sir. So I understand it was not kind of an error or something. It is more of strategic thing,
Yes, yes. It was not a, it
balancing.
was decided, and we had capabilities of going slightly south also, but we never wanted to go there because we wouldn't have got sun to recharge our batteries.
Right, right, sir. That's interesting, sir, because this is quite strategic because we want the batteries to be constantly charged in order to do all those experimentations, and at the same
At the same time,
something
we
which
should
is
be
not
close
understood.
enough to the southern pole to get an
Right.
idea about presence of water.
That's great. That's great, sir. And so in fact, I'll come to a little different kind of a question, not purely scientific, but I have seen the what happened in Chandrayaan-2. Uh, and then ISRO coming out with an idea of making public engaged with this entire plan of landing in Chandrayaan-3. Can you give me some kind of insights, like how did ISRO manage this public engagement in first place? Why was so? And secondly, there was ultimately record was broken. 8 million concurrent views were seen. So was that anything to do with the strategy or something they wanted to? Because Chandrayaan 2 did not go the way they wanted. It was a huge risk in public view.
You see, what happens is that if you're doing science, one
Yeah.
should not be afraid of failures. Because
Right.
it is always said that more than a success, a failure in science teaches you much. So ISRO
Absolutely.
is very clear since day one that they are not afraid of failures. As far
Yeah.
as they were concerned, they were putting 100% or more than 100% efforts to
Yeah.
undertake the system. But you never know. I quoted Chairman ISRO saying that we were prepared for all known unknowns, but there could have been some unknown unknowns also. So that was the
Oh,
basic challenge, and ISRO had no issues as far as facing a failure was concerned. So they were not looking at a public image or anything. They were clearly looking at their scientific capabilities. So they got a huge amount of a transparency in their program. And when you talk of a public engagement, for many years ISRO is engaging public because most of our launches you can see there is a direct telecast which is happening. As far as
absolutely.
internet, more number of hits and all that which you can say, yes, now social media is very active. Internet is reached to the various other peoples also. Maybe say 10 years back or 15 years back, that sort of a spread of internet was also not there. So one should not get carried away just because you got more amount of a hits, because obviously
Correct.
you'll get more amount of a hits because now internet is there in everybody's mobile phones also. But
True.
at the same time, ISRO was successful enough to teach the people in a sense that this is what a science, this is what a space science is all about. And this entire space science is for the development of a country. Our
Absolutely.
forefathers have understood the importance of a space for a development of a country. Because India was always criticized about the debate of bread versus science and all that. That you don't have clean drinking water, you don't have these issues and all that. But when it was decided in the early 60s, we had a wonderful scientific leadership which was provided by Homi Bhabha and Vikram Sarabhai. Shantiswarup Bhatnagar also was there. And we had a intelligent political leadership from Jawaharlal Nehru, who understood that if a country has to make progress, country needs to invest into science. So ISRO space program has always been open for all these years for people to see. Now their engagement of a human, engagement of a young population into science program has also increased. We have already launched student satellites. I think for the last almost 20 years, we have been launching student satellites for various universities and all that. So ISRO has been doing it only because of more amount of media coverage, I think more amount of hits and availability of internet, that could be one of the reasons. But yes, it definitely generated more amount of enthusiasm in the minds of the people.
Correct, correct. In fact, sir, it happened for good because whatsoever common public had thought of at the time of Chandrayaan-2, they could see Chandrayaan-3 not only a success, they could witness that very moment, and probably engaging audience will not only help in getting hits, but maybe some other generation of scientists would also emerge out of these people, those who saw.
In fact, that is the basic agenda of a ISRO, of engaging students community, engaging young community and all that. You see, the generations has to carry forward the agenda of a space science. So that has been the basic agenda, and I can see a lot amount of enthusiasm among young people also. Now India started having their own startups, and other economic ecosystem also has evolved over a period of time. So there is a good amount of attraction towards the space science, one can say.
So when it comes to now Chandrayaan-3, we already achieved what we had thought of. Now, how do you see? Because you're very closely working in that area. What is the future of the space mission when it comes to India after the success of Chandrayaan?
You see, Chandrayaan-3 is a part of a journey. It's not end of a journey. We are planning for Chandrayaan-4 mission. Now what happens is that, you see, if you see globally how the missions progress, and from a science point of view, those missions progress in a particular direction. The next step would be the sample return mission. That means our spacecraft will go, it will pick up a sample from the lunar surface and get it back to the Earth, where our scientists can analyze the sample. Like I was telling you the example of a helium-3 and other things, possibility of a mineral. So until and unless you don't do a physical evaluation of that sample, you will not be able to actually come to know. Only based on satellite photographs, you may not be able to come to know. So the sample return mission will be India's next mission. There is a possibility that ISRO will do a standalone mission similar to Chandrayaan-3, and there is a possibility that a mission along with Japan, which can take a joint mission, could be a mission which will be a sample return mission.
Okay. In fact, sir, as I asked about what is the next future space mission, and as you have happily responded to this, and the very next one is in collaboration with Japan. As we talked about students being associated or being engaged into ISRO's mission, because we want to spread the awareness about the science and the people to develop interest into it. When it comes to your book Chandrayaan-3, I'm sure that you must be having some audience in your mind or some readers in your mind when you pen these books. So, what would you like to suggest to the author, as an author? What would you like to suggest us that why this book should be read and what will we gain out of this?
You see, I would like to answer this question in a slightly different fashion. As I already explained that I am not a hardcore rocket scientist. I look at issues as a space enthusiast. So this book was actually a book which was written to teach myself that how this entire mission has happened. So I think if I'm trying to teach an individual who is not a scientist, so definitely the book has emerged from a point of view from a layperson's thinking only. So my thinking, your thinking, everybody's thinking, like you asked very pertinent questions, why we are landing on South Pole, what went wrong in the second mission and all that. So I also had all those questions. So I just tried to answer those questions which were in my mind as a lay person. So this is not a scientific book. It is a book about a science, one can say.
Correct, correct, correct. So, you know, how will you give the youth by virtue of this book? I am sure that this book must be, reaching out to the people, and they must be reading it. So, anything which you would like to tell them that from this particular point of view, you look at the book, probably you'll get a better insight of this.
You see, as far as the book is concerned, it is a essay on India's moon missions per se, one can say.
Correct,
Major
correct.
focus is on Chandrayaan-3, but I thought that Chandrayaan-3 in isolation will not serve the purpose. So I have started tracing India's journey, particularly from the point of view of moon missions from the 2000 onwards. So I
Correct,
have
correct.
traced that journey, spoken about India's first mission to the moon, that is 2008, spoken about India's second mission, which was partially successful, then spoken about few global missions also, that what is the going to be a global agenda in coming years. Then I have spoken about few rover and lander systems which have already been operational on the moon surface and what sort of information which they have brought. So I have tried to look at the moon from a different perspectives. I have already have some amount of idea which I have given about the geology of a moon also, about how the evolution of a moon also has happened. Because there were a lot of theories which are there. But there is one theory which is now generally accepted by many people, that means many scientific community people, that there was a big planet called Proto-Earth, and that planet was hit by other big planet. And during that hit, one part of the proto-Earth got separated, and that is the moon. So I've tried to give all those sorts of informations. What are the theories which are looking at the moon, how the evolution of moon has happened, what is the atmosphere over the moon? Because you see, atmosphere over the moon itself is challenging. At places, the temperatures go as low as during nighttime minus 200 degrees Celsius, and during daytime the temperature increases to plus 150 degrees Celsius. So what sort of a challenges the scientific community will have to put the systems over there? Because you need to be very careful about what is the material composition of your spacecraft, because the spacecraft has to sustain that type of a very dramatically changing weather conditions, because minus 200 and plus 150. So there's huge amount of a gap in the temperatures from very cold to very hot. So your spacecrafts need to sustain that. So all those aspects have been discussed into the book.
That's great. That's very interesting, in fact, sir. In fact, sir, I would like to thank you for giving us very wonderful insights, and some of the learnings which I imbibed, and probably in our next meeting you would like to, you may see those changes. I'm committing to yourself through this. What I found that, yeah, definitely curiosity is something which really makes man progress further. And seeing something, because I interacted with you before that also, both the times you came out with one particular, you see yourself very humbly as a student of science, student of physics. That is something worth learning, even after writing so many books, even after having doctoral degrees and MPhil degrees, and even in a way, how humble you are in that sense of it. And then you said that this book you have written not to make others understand, but yeah, it's an essay you have written for your own understanding about these particular expeditions. So, viewers, it had been a wonderful conversation we had with Group Captain Ajey Lele. It's a very, even the name, when I read it for the first time, I was quite curious to know, and I spoke with you, and I got a very wonderful answer regarding this. So, another last thing which I'd like to ask before I address to the viewers, what is going to be the next book? As you have already penned down some 10.
Yeah, I've not thought over it, but yes, there's going to be a race for the minerals onto the planetary surfaces. So today, why people are going to moon, there are missions which have been planned to the Mars and all that. So there is going to be a race. And under these types of race sort of conditions, the power which is superior will have some sort of advantage. So whether the world should allow that, because you see, there is a concept of a global commons. That means your planets and other things like high seas is a common heritage to mankind. So one has to really look at these issues as a common heritage to mankind and not get into any sort of a racing to get the minerals and all that. So I'm just thinking on it. I'm not yet decided whether I will write a book on that, but this subject is attracting me a bit.
Okay, that's fantastic. Viewers, this was a very interesting interaction with Group Captain Ajey Lele, and I'm sure that you all are going to be benefited as I did today. And I'm sure that we would look forward to go through not only this book, but the books which are going to come ahead. We'll wait for your further work. And thank you so much for being with us, sir. Your contribution is immense, and the insight what you gave us from a scientific scientist perspective, that is immense. And we are greatly indebted for all your efforts and the scientific fraternity is putting in to bring India on a fore and helping the mankind.
Thank you so much. It was a pleasure talking
Thanks
to
for
you.
spending. Nice talking to you, sir. Thank you so much.
Thank you.
Thanks a lot.